Hi guys, today we're going to be doing precision measuring of machine parts. So we have this diagram right here. We are requested to find this, the diameter of the roller that we have right here, okay? So as we are given, the length of where the diagram starts to where it ends is 70.25 millimeters, and the length from here to there 55.13 millimeters. The angle formed here is 60 degrees, and yeah, that's all that we're given. And the length from here to there is 35 millimeters. Okay, so first off, we will start by finding this angle right here. Okay, since we know that this and this are the same due to alternating angles, we will say that this is 60 degrees. Okay, 60 degrees. So knowing that this is 60 degrees, we know that two lines that touch a circle, the point where they join, right? This is the point where they join, the two tangents. When you draw a line from the center of the circle to the point where the two tangents join, it splits the angle into two equal parts. Okay, so here it is the line from the center of the circle to the two tangents where they meet. You have 30 degrees on both sides, which is still 60, 30 and 30, still 60, right? Okay, so having this, we will label our triangle. We have a triangle here, see, with center O, right? So let's say this is A and this is B, right? So in triangle AOB, right? In triangle AOB, in order to find our AB, we want AB, right? We want AB. So we'll say tan 30 degrees is OA, right? It's opposite over adjacent, which is AB, right? So having this, we can say that where is our, okay, our calculator. We can say that, let's punch in first tan 30. What's tan 30 degrees? Tan 30 degrees is 0.577 is equal to OA over AB, right? We can make AB the subject of the formula. AB is equal to OA over 0.577, right? We can also write this as, by opening our brackets and raising this to the power -1 to have just a solid answer. Okay, we can say 0.577 to the power -1. We will get 1.733 OA, right, which is our radius OA. Okay, that's AB. Let's rule it off like this. This is OA. Okay, then now we can come to this side, because here we can't continue any further until we get the value of OA, okay, or we get the value of AB. So we have a triangle again here. Okay, let me show you this. We have a triangle here. If you do this, you will have a triangle. Yes, you have a triangle here. You see it? It will be a right angled triangle, right? It's 90, 60, meaning that here's 32. Okay, it's also 30. Yeah, it's also 30. So having this, let's label our triangle here to find this length. We want this length. Reason why we want this length right here, this from here to here, the reason why we want this length right here is because we want to be able to find this length right here. In order to find this length here, you have to say this length 55.13 minus this length, you get the length from here to here. Okay, let's firstly label our point. This is B. Let's call this E, and let's call this P. Okay, and we can call from this point here to there, we can call it point S and point L, for instance. Okay, we know that. Okay, we have this triangle, so we know that our PB is 35 millimeters. Okay, to save space, no need to write PB is equals to 35 millimeters, because we can definitely see that PB is equals to 35 millimeters. So what we will do is find this length right here. We will say tan, this is 30 degrees, bear in mind this is 30. So we will say tan of, this is the opposite, right? Tan of 30 degrees. EP is our opposite, EP over our adjacent side, which is PB. Right? See that? So having this, our PB is 35, right? So we can say 35 tan 30 is equal to EP. Okay. So 35 tan of 30 degrees, you get 20.207 is equal to EP. But you have to specify if it's millimeters or meters. Mostly they will penalize if you don't specify your units, so it's very important. So yeah, since we have EP right here, we can find the length from B to L, right? Let's just do this. This is the same B, so that we are not confused, right? It's still B here, it's still B. So you have to find this length B to L. Okay, as we said, let me rule of this. As we said there, that in order to find it, we will firstly say that 55.13, right? 55.13 minus EP will give us BL, right? So we know that EP is 20.207, so 55.13 minus 20.207 will give us our BL, right? So it's 55.13 minus 20.207. You will have 34.923 millimeters is equal to BL right there. Okay, so we found our BL. So having found our BL, we can say now, we can look at our formula, our overall formula, okay, of what is SL. What does SL compose of? It composes of the radius here, so we'll say that, let's write it here, SL, right, is equal to the radius, this radius right here, it's equals to radius plus AB, right, AB plus BL, okay, since we have SL as 70.25, the radius, don't have that, that's what we're looking for. AB, we found it as 1.733. OA is radius, so we can just say multiplied by radius plus BL. Our BL is 34.923. Okay, so we can transpose our 34.923 to the left hand side. We will have 70.25 minus 34.923, which will give us 35.327 is equal to 2.1733 Now 2.733 R. The reason why we say 2.733 R is this one right here, this one, plus 1,1733, right? Which will give us 2.733 R. Okay, so having this, we will divide our 35.327 divided by 2.733, which will give us 12.926 millimeters as our radius, but we are looking for diameter of the roller, which is 2 radius, right? So the diameter is 2 times 12.926, which will give us 25. The diameter is equal to 25.85. Yeah, that's your answer right here. So guys, yeah, that's the end of our lesson right here. I hope you understood this. This is very simple, but obviously meeting it for the first time should be difficult. You know, you should have a bit of difficulties here and there, but once you solve it the first time, you are less likely to forget it again. So guys, from me to you, I love you and leave you. Take care. Thank you.